Friends, in this video, I'd like to showcase how to use Python to write our own code to test the LFI vulnerability or local file inclusion vulnerability. As you know, the local file inclusion vulnerability allows attackers to retrieve the content of the sensitive file like password file, like log file, the authentication log file, or any other available file on the target system. So this vulnerability is very dangerous. Although we can test or discover this vulnerability manually, some case we need to use the Python to automate this process. Also, writing in Python can help us to understand this vulnerability better. So this is the purpose of this video. Without further ado, let's just get started. We can switch into the Kali Linux, and as you can see over here, I use the DVWA as my target application. And as you know, we can use the up directory, the // to go wherever, right, of the file system. For example, we can use as many as or enough numbers of the up directories to the root directory, and then we can get to the intended file. Okay? So by utilizing this method, we can test whether we can retrieve the content of the specific file. And always we will test, we use the password file as the target to retrieve, because this file is available in all systems if the machine is Linux. Similarly, for the Windows machine, we just use different file name or use different file to test. All right, so now we can go to PyCharm editor. To start our coding, we can import the requests module. This module can allow us to construct request and then can send the request to the target or to the web application, and also can receive the response from the web application. And also I'd like to import the sys module. This module can capture the input by the user. For example, user can specify the URL, the parameter name, because different web application will use different parameter name. And also, some case we need to specify the cookie, because in some case we need to get authenticated first and then test whether the target has LFI vulnerability or not. Okay, so now we can put the if conditional name, the main, and then we can use try and except to capture any, not any, just index error, except index error. And then if capture the index error, it means that the user didn't configure the program properly, we can print out the usage, the base URL, and followed by the parameter name. Of course, in this case, the parameter name is page, all right? And then we can also, some case, just I mentioned, we need to specify the cookie value. Of course, you can get the cookie value from the, for example, we can open up the developer tool of the browser, and then here you can copy this cookie information. Although this is in the format of a string. To use this cookie value, we need to convert it into the JSON format. So next we need to make some sorts of a processing in order to use such cookie. Okay, and for now I think we can maybe, okay, it's okay. Now we go back and sys archive. The program name is the first element in the sys archive list. You know, sys archive is a list including the program list and followed by the arguments. Okay, and we can print some example. For example, HTTP. Maybe we can copy this into here. Remove the, okay, and also we need to specify the parameter name. This case is page, and also cookie, and cookie data archive the 0, and then we can exit the program. If no such error, we can save the user's input to the specific variable correspondingly. Okay, sys archive the first element, and the second one is parameter name, sys archive. Oh, sorry, not 0, and the 2. And next there will be 2 cases. Some case we do not need to specify the cookie, but others, this would be required. Some local file inclusion vulnerability exists only if we can get authenticated first. Okay, so if length of the sys archive is equal or larger than 3, and then the cookie string should be sys archive false. Otherwise, else the cookie, not this cookie, string is long. All right, and then we can pass such arguments to the function. Although we didn't define the function yet, main, the base URL, and the parameter name, and the cookie. All right, so next it's time to define the function. We can define the main, the base URL, parameter. Maybe I can copy. We can use the same name. Okay, so how to do? And we need to, so the URL should be like this one. We need to concatenate the, we can concatenate the URL, and we can put here for reference. Okay, so it would be like that, would be like this. So we can for I, and of course we need to define the up variable, the // slash. So this we can put, for example, the first, the up is 0, and then 1, 2, 3. We can make a loop through until we can find the location where we can retrieve the content of the password file. Okay, so for I range, I think 10 is enough. So this will be the limit. And then, of course, also we need to have a conditional if I is equal 0. And then the URL should be like this one, the base URL. And put what? The question mark. Okay. So we can use this one. We can the as the placer, the placeholder, and then followed by the question mark and another placeholder. Okay. And then we can put the base URL, parameter name, and we can plus or concatenate the etc password file. Okay, I think no error. Else URL should be, we can copy this, and also we can use the multiply up, and then etc password file. Okay, then we can send the request. So next also we need to have a conditional if none, if not cookie string. It means that the user didn't specify the cookie, so we just sent the request URL without cookie. Otherwise, the response should be request get URL, and the cookie. Of course, we need to process this cookie just mentioned. At this moment, the user specified cookie data is in the format of a string. We need to convert it to the JSON. So how to do? We can define the method, process the string, and the cookie string. So how to do? Because we know the cookie would be like this one. We can copy and we can paste in here. So the cookie we need to do, first of all, we need to split by the comma. Okay, so how to do? We can, so for each in, of course, we need to define the cookie dict, the dictionary. At this moment, no any key or value. And then we can for each in cookie string, not string, split by comma. And then, so the key would be each. So also need to make another split separator would be equal, and the first element should be the key. Okay, so how to do? We can cookie dict I hope you can understand what I'm doing. And then we can each split the second. Okay. And then we can return the cookie dict. So why the is error cannot assign to function call? Okay, not this should be this one. Okay, so now we can pass the cookie without a problem. Should be process string, the cookie string. Okay, and then if response status code is equal to 200, which means that successful, we get a success. And then if root in response text, and then we can print the LFI vulnerability exists on the target. Even we can print out the URL, the current URL, right? And I also want to retrieve the content of the password file itself. I do not want any other gibberish data, for example, like any text or any other content in the page, in the web page. So how to do? We can for line in another loop, response text, we need to convert to list, and then we can, if, as you know, we have pattern, we can cut out the password file. If the is X and surrounding by the column, it means that this line or this element belong to the password file in line, and then we can print out the line strip. Okay, also I think it will be better we remove any space. Strip. Okay, I think it's time to test this program. Hopefully, no, if we get error, no problem, no worry. We can FFI, and so we can get the cookie. We can copy this cookie. Also, we just run. As you can see, we will be given the usage and example, and we can paste in here, press enter. So the cookie, so I think there will be some error. We need to sort it out. So what's the error? Strip. Oh, okay, this error. So now we can run it again. Why is this? The cookie. Maybe I can print out the cookie dictionary to see. So we need to do some debugging, right? No cookie. So the main cookie. Maybe here we can print out the response text for the purpose of debugging. No? Why is this? So response get. So maybe I need to print out the URL. Maybe URL is not correct. Why? Oh, this should be 3. Sorry about that. We can run it again. It looks like our program works properly. So then we can comment out some lines. Such lines are for debugging only. Now we can test the program. As you can see, we can test that, of course, if we, as soon as we found this root, it means that we have already confirmed this vulnerability is there. So then we can break. Do not need to continue this loop again. Okay, this makes sense, right? We can, as you can see, it works properly. Okay, so that's pretty much it. I'd like to see you in the next one. Bye. Have a nice day.